Hi, my name is Prateek, roll number 20EC10057. I'm from section 14 and this is my second DIY assignment named Social Distancing Meter and Alarm, which I've made on Tinkercad. So this is my model. I've got all these components from this toolbox on the right side. Uh, this is the main microcontroller of this project, Arduino Uno board. This is the breadboard on which all the other components are fitted and connected to this board. This is the piezo buzzer. This is the 7 segment LED display. This is the ultrasonic distance sensor for measuring the distance. So in this what I did, a total distance of 300 centimeters, that is 3 meters. I divided that into 5 regions and I ranked them accordingly based on in how much close proximity a person can get. Like for example, it will be something like this. If a person is from 240 centimeter or between 300 also, it will be displayed as 1. And let's say from 180 centimeter to 240 centimeter, it will be in rank 2 and so on and so forth. It means that if a person crosses this 60 centimeter, then it will be displayed as 5, fifth rank here. That is the in the very close proximity. That will set off an alarm to warn that now there are chances of getting in contact. So that is the logic. Now let's check on the code. So this is the all the initialization process of all the pins which I have used. Now this is the void setup. This will run just only once. So in this you can see I've made a for loop. This is because as you can see I've used all the pins from 2 to 13, and out of which from 2 to 12 they are all they're all output pins. Only just one, that is the echo pin. This is only input, so I've declared that once. So instead of declaring each and every pin mode, I've used this for loop from 2 to 12. From 2 to it will run to 2 to 11, and this one separate 12th pin I named it separately as input. This is serial begin. This is used for printing stuff on the serial monitor. I don't think we need it right now, so let's comment it out. So this is the loop portion. It will be keep on running unless we stop the simulation. So I've taken two integers d and right. So from in the d variable I will measure the distance. And how will we do? This is the measure distance function which I'm written just here. So in this function, actually what this sensor does, from its left part it sets off a pulse, and the right part it is collected back as it is reflected by any solid object in front of it, and this sensor calculates the time. Here is the time which I got from this pulse in built-in function, which will give me the time in microseconds. So, and I have to calculate distance using that data by taking 340 meter per second as my speed of sound and dividing it by 2, because the time it gave was the total time in the whole journey in the setting off and setting on also. So I got my distance from here. I will return this. So now my d variable has the distance, and now here is the division of all my 5 levels. This is the condition, like if it is below 60, then it will be level 5. This will be if below 120 and greater than 60, it will be level 5, so on and so forth. So now the task is to display this level on this 7 segment LED display. So how will I do it? This is the display function which I have written just below it. This is the display function. This will take the integer, and this is a very long function, but the logic is very simple. What takes place is that this is a 7 segment LED display because there are 7 LEDs in this 8 digit which you can see, and this is also an LED. So basically this small dot. So basically there are 8 LEDs which I can control, and these are all the 8 LEDs are connected separately by these wires and this resistor to this microcontroller. I can control each and every LED separately. So if I want to display one, I will turn on these two LEDs and turn off all those other LEDs. So that is the thing which I've done here. So after this, I've displayed the level, and now the condition for the alarm comes. If the level is 5, that is it is in very close proximity, then I will set off this buzzer using this built-in tone function of 220 Hertz frequency and 100 time. That is in millisecond. And after that, there is also this LED which I set up. So I will calculate this brightness. Actually I have mapped this D function. D was the distance from 0 to 300 to 0 to 600. This is an analog meter, and I've written analog right to this LED pin, and I've given this value to it. So basically it will give a measure of its brightness will determine how close a object is from the sensor. Then I put this delay. So that's it. Now let's see the simulation. So as you can see, this is showing 1 because its distance is 286 centimeter, that is between 240 and 300. It is less than 300. Even if we go beyond 300, it's very low chance of any contact, so it will be still be displayed 1. Now let's decrease the distance. Let's keep it below 240. Now this is changed to 2, the second level. Let's decrease it again. Now this is displaying 3, the third level. Now it's less than 120, so it's 4th level. Up to 60 it will be 4th level only, and as soon as we cross the 60 centimeter mark, it will display 5, and this buzzer should be on. And as you have seen, when this buzzer was, we can see this rating on the voltmeter. So the simulation is also working fine. So that's it. Thank you for watching.